important that I'm going to put it on the board to make sure that you know, I can at least say, hey, I had it on the board. The arcsine arcsine's derivative and arctangents for sure get those memorized.
Do we need to memorize them in terms of y and x or just
x? X, just in terms of x. So you need to know that if you take the tangent function, the inverse tangent function, and take its derivative, it's 1 over, you can write it two ways. You can either do x squared plus 1, or you could do the 1 plus x squared. You could switch the order on the bottom. You need to know that, all right? I'm going to put stars next to it. That way later on I can tell you, hey, remember I put it up there and I said I put some stars next to it, told you to remember it? Okay, please hardwire that. All right, now, with that said, I'd like to do a couple of problems real quick. First problem I want to do, I cannot believe I don't have much time, is this. If I asked you right now to take sine, okay, the sine function, just sine, and inside of it x cubed plus x squared plus 1, let's call this thing y. And I ask you to do the derivative here. That's kind of like what I handed to you at the beginning of class, right? It's kind of like what I handed to you. I'm just asking you to find a derivative. Show me what you remember from Cal 1. So this would be chain rule, right? Start out by saying, what's the derivative of sine of something? You'd write cosine, x cubed plus x squared plus 1. And then chain rule times the derivative of what's in there. Right, that would be the derivative. I hope that that seems like kind of easy for you. Yes? This is a chain rule problem. The first step of the chain rule was you had to know what the derivative of sine was, right, to get this piece, right? You say, oh, you just take derivative of this is cosine, and then put the argument in here, and then you work with, continue with the chain rule. The reason I'm showing you that is because now I want you to see that we have 6 new derivatives, and all of those can be implemented with what we learned in Cal 1 in terms of product rule, chain rule, quotient rule. All that is fair game with these 6 functions. So if I instead write this down, I ask you to find y prime. What's different, right? I'm asking you to find the derivative of the inverse sine of this. Right? What's the derivative of the inverse sine of this? Not sine of it, but inverse sine. So we're going to use the formula, but we have to implement the chain rule. So the first thing I do is I say, all right, what's the derivative of arcsine of anything? So on our formula, right, the derivative of arcsine of x would be 1 over the square root of 1 minus that x squared, right? Whatever the x was squared. But here, our x is not x, right? It's this entire big chunk of shit right here, right? So it's going to be 1 over the square root of 1 minus all of that squared, right? It's going to look ugly. 1 over the square root of 1 minus, I'm just following the formula, all of that squared. And all that does is takes the derivative of the inverse sine of this, right? What am I still missing? The chain rule part, right? So times now the derivative of the argument, which will look exactly like this, won't it? That's it. Yeah, you could slide this up top. That's about all I'd care for you to do. And I sure as heck don't want you to expand this. Don't worry about that. The main point here is to show you that, look, everything we did in Cal 1 we knew the derivative of sine, cosine, tangent. Now we can do the same thing, but with these, using those 6 formulas. Let's do another one. Let's let y be equal to, how about this one? x squared tangent of the square root of x. And I want you to find y prime. So I want you to try this one. I want to give you 2 minutes to see how much of this you can do. If you want to talk to your neighbor, that's fine with me. But I want to see if you can get this in 2 minutes. Just take the derivative. You don't need to clean it up, make it look pretty. Just get as much of it as you can. Oh, do you need, oh, I wrote it up here though.
Oh, my bad.
Yeah, I wrote it up there. If you finish it, raise your hand. You don't need to keep it up. I just want to kind of see how long it's taking people to finish this. Did everybody get a copy of the quiz and the solutions? You need a copy? You need a copy? Are there any extras? You got it? Okay, hold on. All right. What's the quiz? These are the answers, but are there any extra answers for the quiz? No? Take a picture. One of you can take a picture, yeah. That's due in a week. Oh, there's extras here. Here you go. There's, those are due a week from today. Even though I'm giving you the answers, I still want you to like turn in a physical copy of your work, okay? Okay, so we had one finish. Who else is done? You got it? You got it? Do you have a question or? I'm going to start working it out. I'm going to work it out. I'm just going to silently work it. We'll talk about it. I know what you're mentioning.
We're just doing it in reverse.
'Cause, like, I do the
I'm doing the
derivative of
derivative of g of x.
And I do the derivative of f of x first.
So when we compare our work, it's the same.
It looks
answer,
different.
just flipped.
Yeah. We'll talk about that. We'll talk about it after we do this because there's an important thing there. So as you're sitting there wondering like, what the hell? Product rule, right? So product. X squared times the inverse tangent of the square root of x. So you've got a product. So you must employ the product rule. Now, I already know because you were all coming from different calculus classes, everyone here has probably learned the product rule different than the way I just did it on the board, because this is not the format that the textbooks uses, right? So shall we address that now? I'll address that now. So hold off, time out. A lot of you were taught that if you have f times g and you want to take the derivative, you were taught what? G prime first?
No, we did f of, wait, yeah.
So f first times g prime? Is that what you do? Yes. And then add to that, what?
G times f prime.
G times f prime. Show of hands, how many of you learned that way? Ooh, almost all of you, okay. Do you remember the quotient rule then?
I don't know if it's f prime of x or g prime of x.
You don't know which one?
I think it's f times g prime of x minus g times f prime of x divided by g squared.
I agree with the g squared.
Did I mix up the base?
I think you may have. Someone help out?
Yeah, it's
What is it?
F-
Don't, not yours, not the one I taught you. I want to know how everyone else learned it.
Would it be g times f prime minus f times g prime?
Minus, right? And then f times g prime? Is that what you? Okay, most of you, this is the way it's taught. Okay? That's fine. I'm not here to reteach this. All right, this is Cal 1. But this is not the way that I work it out, and there's a reason why. When you're learning this, at least when I was learning this to me looks too much like two different like formulas. Like look at this one. Fg prime plus gf prime. This one is gf prime minus fg prime, and I start to like mix it up, right? It starts to, I get confused, like which one goes first, right? When I was a student, this is the way it was taught to me. And it seemed too much to memorize. And then I realized that, you know what? That's exactly the same as this. If you do this, change the order of the top one to be, what did I teach you? F prime G, F prime times G plus G prime times F, right? This is exactly the same as this. I've just switched things and then commuted the multiplication. So that's the same. Y'all agree our derivatives are the same? But look at the beauty of the quotient rule though. It's this formula again. It's exactly this formula again, but with a minus between them. Okay? Same formula with a minus, and then divide by g squared. So as a Cal 1 student, the only thing you have to remember really is the f prime g, g prime f. Then it's just a matter of if it's product rule, it's plus. If it's quotient rule, it's minus. And then divide by g squared. Instead of this, which to me is just too much stuff to mix up. That's just my opinion. So this is the way I teach it. Yes?
I do quotient, my teacher taught Lodi
Lodi yeah. So there's other things, little cute acronyms and things like that. So I don't care how you do it because again, this is a prerequisite topic, but we should all get the same derivative. Like it might be out of different order, different arrangement, but it should be the same thing. All right? So over here, I did product rule, which when I do it, I always do the derivative of this one first times this one unchanged. Don't touch it. There it is, right? Then I say plus, and now I take derivative of this. This is the tricky one. You're taking derivative of arctangent of something, which is going to be 1 over 1 plus whatever that something was squared. So I'm using formula, well, this one, right? I'm using this. Oh, and I switched it. I did the 1 in front of the x squared. Is that all right with you? But what the heck is this?
It's the derivative.
Chain rule. I had to take derivative of the square root of x. Now, again, this goes back to your Cal 1. When you learn the derivative of the square root in Cal 1, how did you learn it, right? I teach my Cal 1 students to just burn into their brains that this is 1 over 2 root x. Just burn it in. We take derivative of the square root of x so much, just memorize that that's what it is. You may have learned it like write that as 1/2 power, and then bring the 1/2 out, and then subtract, and use a power rule. But we get the same answers, right? I mean, like you can take that and drop it to the bottom, turn it into a square root again, you're back to this. So we have the same answers, just might look different. And then what's this? Oh, we remember product rule, you have to bring that first function in here without the derivative. Now there's some algebra I can do to clean up, right? I mean, like I could maybe put these together, slide things over, but that's the raw derivative. Questions? I'm almost out of time. Yes, Ash? Oh, yeah. This is going to turn into an x. I just wanted to make sure everyone saw the chain rule happening. As quickly as you possibly can, pass this around the room. Just put your quick little initial next to your name. I'm going to try and do attendance that way. We have 3 minutes. Okay, I want to look real quick at the homework because there's stuff that I don't think you're going to be able to do. Well, there's stuff that you may not be able to do. So let me just check. You're supposed to do problems 1, just hang tight here. Okay, let me see here.
And then Thursday we have both of like this summer, from 5:30 to 9 p.m. Or I get home.
All right, so I just want to do a quick thing while you're waiting for that thing to come around to you. For the homework, you're supposed to do problem 1. I'm just giving you a quick hint here. Problem 1 has nothing to do with calculus. This is a pre-calculus problem. Okay, problem number 1. So go ahead and do that, see how it goes. Number 5 is also a pre-cal question. I know people are going to struggle with it though, just historically. Pre-cal's been a while, okay?
Is the answer not just 10?
What's that?
Is the answer not 10?
Well, maybe. It depends. Like for number B, for part B, it's not 7 pi over 3. The answer is pi over 3, but why? So you need to go back and recall why it is when you're doing inverse. There's domain restrictions and things. So, okay, see how that goes. Okay, look at number 15. You're supposed to prove. Wait a minute, crap. Okay, yeah, we did cotangent inverse, right? So here's cosecant inverse. Prove that that formula is this. So you should be able to do 15. 16 through 28 are all derivatives using chain rule, product rule, quotient rule, but now you have all these new 6 derivatives, right? So I think you should try 16 through 28. All I did was what? 2 examples? Okay, I did 2 examples, so that's your practice. See how it goes. 32. I didn't really talk about 32. 39, yeah, so why don't you just do what you can up until, don't do these yet, okay? These, I will want you to do those, but just for now, do those. You're not submitting anything to me, right, yet? You don't submit anything to me until we do 3-6, right? The hyperbolic trig functions, we do that next class, and then you'll have the weekend, then you'll submit your homework to me. Yes? Well, no, because I want 3, 5, and 3. Well, if you have 3, 5, and 3, 6 together, yes, you can do early, but not just here's what I have for 3, 5, 3, 6 is coming later. I want it all together. Yeah. No, leave the computers down. For those of you who came in a little bit late and may not know this, there's a button over here on your desk that raises the computer up out of the screen, out of the table. We might use these, so I just want you to know it's there, okay? Does anyone have any other questions? Y'all can go. If you signed in, you can go. Sorry, I don't mean to keep you late the first day. Yeah.
About my final. I know you have the
Let me turn this off.
Sir, I was thinking about it.
Yes.